Welcome to Cadence Design Systems Fidelity Tutorial Tuesday, where we show you how to use a feature or demonstrate a technique in just a few minutes. Today I'd like to cover the question of enforcing periodicity in domains or surface grids in Pointwise, while at the same time using the T-Rex anisotropic method to initialize layers in an unstructured block. My example today is a fairly simplified case, but it does have a couple of periodic boundaries, and if we look down the x-axis for this particular setup, you can see that it is a rotational, almost a rotationally extruded topology. And so what I'd really like to do is enforce periodicity between these two domains on the sidewalls of this topology. I do already have a block defined in this particular case, and if we examine cell type for this block, for example, and enable a cutting plane, an X cutting plane, we can see that I do have T-Rex layers at the hub of this topology or geometry, and also at the shroud, what I've created here as what would be a shroud. But in this particular case, if I look at the domains in the domain list, they are just regular domains. There is, other than the names that I've applied here, they do not indicate that they have been connected or that they're slaved together with periodicity, which is what we would like to have. The main thing to remember for periodicity with Pointwise is that it has to be set at the domain level. And what you want to do is use the create periodic command to create either a translated or a rotated copy of an original domain or surface grid, and then the copy becomes slaved to the original, and any changes made to one will automatically be reflected in the other. What I need to do is actually delete one of this particular set of domains so that I can create a new periodic copy of the remaining one into the other side of the block. Doing so is of course going to delete the block as well when I delete the domain. So I'm going to just select this domain on the left in the view that I have here, use the delete key on the keyboard, and you can see in the messages that it did delete the block as well, which is an unfortunate consequence but necessary in this case to create the periodic pair. So I select the other periodic domain we can see here, periodic-1. I go to the create menu, pull down to periodic, select rotate, and I know that this is a 10-degree rotation through this particular topology or geometry, so I'm going to go ahead and set this up as 10 degrees for the angle, and then I'm going to define the axis using point and direction, and the axis in this case does pass through the origin of the system, so 0, 0, and 0, and X is already selected, and so all I really need to do here is hit enter for my angle, and it generates the new periodic copy for me at the other side. This looks great. I'll go ahead and select OK. Also, if we look over here in the list for domains, I can see now that periodic 1, which is the original that I kept, has in parentheses periodic DOM1 or DOM-1. So that's the newly created domain, and these two are linked together through periodicity. Any changes made to one will automatically be made to the other. So in order to complete this process, all I really need to do is to recreate this block that I already had using this new periodic domain, and then initialize that block again, which was going to require me to go ahead and set up a boundary condition for T-Rex on this newly created domain. So all we really need to do is select all of these domains, ensure that we are creating an unstructured block topology, and just click on Assemble Blocks on the toolbar. In the messages, I can see that 0 blocks were created. Well, what's going on here? This happens sometimes when you create a copy like we've done and move it into a new position, either through periodicity or just a regular transformation. So what I want to do is look at the topology surrounding this new domain and see if somehow I ended up with some duplication of my connectors, since when it makes this copy, it does take all of the connector topology with it. So going into the grid merge command, I can see indeed that I do have 4 free connectors, which essentially means that I've got connectors that are used only once. They're not being used in a manifold connection like most of the rest are around the perimeter of the block, indicated by the light blue color. So what I need to do is to go ahead and get these connector pairs merged together. I can do that using merged pairs of entities. If I enter a tolerance here for automatically finding candidates, I'll just enter 0001 for my tolerance and hit enter. It does come up with 2 candidate pairs of connectors. I can highlight them in this list, and you can see the highlight in the display window at the same time. So I'll just select all of these and click OK to have those 2 sets merged automatically. Pointwise is going to recognize that I have a periodic pair here, and it's going to prefer to keep the connectors as necessary to maintain that periodicity for me automatically. So now if I select those domains again, and I can use the hyperlink in the messages window to do that, and then click on Assemble Blocks, I should get 1 new block, which is exactly what I expect. Changing my mask to select blocks again, I'll mouse over the block, select it. I'll go back into the grid solve command now for this block. It is, of course, empty because I had to delete that domain, which deleted the block. I'll click over to the T-Rex tab, go ahead and set up some parameters here for T-Rex again. So I want it to be able to march up to 50 layers. And I'm not going to use the default growth rate. I want something a little bit finer than that, so I'm going to use a 10% growth. And I do want it to push the layers onto the boundaries as it grows. And then per boundary conditions, some of these are already set up for me, and that's because it remembers these with the surface grids of the domains, even though I deleted the block. Those attributes or those boundary conditions are associated to the surface grids or the domains. So I really just need to set up a new boundary condition for this newly created periodic domain. I can do that by selecting it. You can see it is one of the one and only unspecified boundary condition. Check the box next to periodic, and then finally once I've done that, all I really need to do is just to go back to the Solve tab itself and click on Initialize to reinitialize the interior of the block.
If you like this video, be sure to click the thumbs up button or subscribe to our channel for more videos like this. If you have any questions, comments, or suggestions, drop us a line down below or connect with us via LinkedIn, which is linked in the description. Thank you all, and have a pleasant Tuesday.